Okay, this unit will be on, this lesson will be on graphing through transformations, graphing lines through transformations. It's really not much different from graphing lines, just got to get sort of used to the terminology. For example, if you had a graph that looked like this, okay, y equals 2x minus 3. Now the way we would graph that is we would start at -3, and then we would rise to 1, 2 over 1, okay, and you graph it, okay, and my graph there is in blue, okay. Now, let's apply some different transformations, okay, transformations. Let's say it said shift it up 2, okay. Now, what that means is, what you're going to do is whatever the y-intercept is, okay, up means positive. So what I would do is I would add 2. So what I'm going to do is I'm going to graph the line y equals 2x minus 1. And what that basically is doing is taking this point, moving it up 2 spaces, okay, now I'm going up 2 over 1, and there's my line, okay. So that's an example of a shift up 2 in green. Okay, let's say I said down, a shift down 3. I'll do that one in red. Shift down 3. Okay, well that would mean that if my blue line here is y equals 2x minus 3, okay, shifting it down means negative. I would subtract 3 more. That's 2x minus 6. So really I'm moving this down 1, 2, 3, 4, 5, and 6. Notice how this is shifted down 3 spaces, up 2 over 1. Okay. The red line is an example of the shifting down. Okay. Let's say the last one, last type of transformation, okay, is to make it steeper. Okay. Now, anything that's steeper, if you look at the slope, my slope is at 2, okay? A steeper slope would be this way. So anything that I would, let's say, instead of going up 2, let's say I went up 4, okay? That's going to be a steeper slope. So from here, it's up 1, 2, 3, 4 over 1, okay? And so my black line there is going to be steeper, okay? So here's the summary of this, okay? All right, shifting up means add to the y-intercept. Okay, shifting down means subtracting to the y-intercept. Making something steeper, okay, is really multiplying the number in front of x by another number, okay? All right? So you got to get used to the terminology. For instance, let me give you another example. Let's say it said f of x equals 3x. Now, f of x is just a fancy symbol for y. So don't get all thrown off because you see the f of x. F of x is a fancy symbol for y. Let's say it said make it steeper, okay? Good rule of thumb is, you want to make that steeper, just go ahead and multiply that by 2. So what I would have here is y equals 3 times 2 with x. That would be y equals 6x. Okay? Now, let me graph the original in green. 3x, if we got this, the y-intercept would be 0, up 1, 2, 3 over 1. Okay? A steeper slope of this would be still 0, but up 1, 2, 3, 4, 5, and 6 over 1. Okay? So your graph there would look like this. Okay? And that's what steeper means. Okay? All right? Let's say I had this example. F of x equals 2x. And I said shift up 5. Okay? So what that would mean for me is normally this graph would look like this. All right, it's 0, up 1, 2 over 1. Okay, shifting up 5. So what I would do is I would add 5 to 2x. So that's up 1, 2, 3, 4, and 5 over 1. Okay, All right. Whoops, I'm sorry. Let me fix that. I didn't do that one right.
Mrs. Gahagan, please call 6551. Mrs. Gahagan, 6551.
Okay.
Thank you.
So I would start up 5, and now I'm going up 2 over 1. Okay. And there's an example of that. Let's say I had another one. Let's say I had f of x equals negative 5x plus 6. Okay. And it said shift down 4. Okay. So my original line, 1, 2, 3, 4, 5, and 6, down 1, 2, 3, 4, and 5 over 1. Okay? All right, shifting it down. So what I would do there is, instead of y equals negative 5x plus 6, I would subtract 4. So that's y equals negative 5x plus 2. So I'm right here at 2, down 1, 2, 3, 4, 5 over 1. Okay? And let's go ahead and do one more one of these. Let's say I have f of x equals negative 3x. Let's do negative 4x. Negative 4x plus 3. Let's say it said make it steeper. Okay? Well, what you can do is you can multiply that number by 2. So y equals negative 8x plus 3. Okay? All right, so up 1, 2, 3. Okay? All right. What it was before, this example would be down 4 over 1. Okay? But now, if I graph this one, I'm down 1, 2, 3, 4, 5, 6, 7, 8. Okay? This is a much steeper line. Okay? And that's graphing transformations. So in the end, steeper means if you multiply that, it makes it steeper. All right, shifting up and down is just adding or subtracting to the y-intercept for whatever they give you. Okay? I want to shift directions and now talk about direct variation. Okay? In some of these questions, we've been going over direct variation. Okay? Direct variation. Okay? Those are equations that look like this. Okay? If you notice that we've been graphing these all along, direct variation has y and x, okay? Basically has no y-intercept. Okay? Or actually probably not no y-intercept, has a y-intercept that equals 0. Okay? So what that means for me on each one of these graphs, okay, is like if I was graphing that, I start here, then up 3 over 1. Okay? All of the graphs, let's say this is graph number 1 in green. Okay? Let's say this is graph number 2 in red. Up 1, 2 over 1. Okay? Let's say this is graph number 3 in blue. Oh, whoops, I did the red one wrong. Hold on. Let me go back. Okay. Wasn't paying attention there. Okay. I should have gone down 2 to the right 1. Okay. This one graph is in blue. We'll call it graph number 3. That's up 1 over 1, 2. Okay. And then let's call this one in the black line number 4. That'd be down 1, 2, 3, 4, 1, 2, and 3. And if you notice, all of the lines, they have a y-intercept of 0, and it crosses the origin. Okay? So that's how you can tell direct variation graphs. Okay? The other thing I want to cover with direct variation is, let's say I had a graph that looked like this. Okay. Okay, and here would be the directions. It would say something like, plot 2 more points. Okay, now, what you have to do is figure out, if I'm from the center, what did I do to do that? Well, I went up 1, 2, 3, 4 over 1, 2, and 3. So I went up 4, right 3. Okay, that is basically your slope. Okay, so to get 2 more points, if I went up 4 more, 1, 2, 3, 4, up 1, 2, and 3, there'd be a point right there. Okay, so basically I'm graphing 2 more points on the line. Okay, I can also go back this way. All right, 1, 2, 3, 4, 1, 2, and 3. Okay, so the bottom line is you want to keep that relationship. Okay, let's say I had this. Okay, 1, 2, 1, 2, and 3. Okay, and they wanted me to graph a couple more points. So what I would do is I went, okay, 1, 2, 3 up and 2 over. 3 up, 2 over. Okay, so what I can do, I can keep this going this way. All right, by going, all right, 2 over, 1, 2, 3 down. Okay, I could go 3 up, 2 over. As long as you keep that relationship the same, you'll notice it will all be aligned. Okay? All right, so what you have to, oops, that was drawn very badly. Okay, you'll have a grid to work off of. All right, so direct variation, a couple things to know. Okay, direct variation crosses the origin. Okay, has a y-intercept of 0. All right, to get more points on that, you just keep that rate going or that slope going. So if my slope here was 4/3, I can keep going with 4/3. Okay, I can keep going in that direction. Up 4 more over 3. Up 4 more over 3. Okay, if it was this way, all right, down 3 over 2. All right, so you can use up, down, as long as it's going in that area. Okay, all right, 3, 2, 3, 2, 3, 2, 3, 2. You can get more points. Okay, and we're going to cover a lot more with direct variation later on this year when we get into equations. But what you have to know is how to graph it and how to find more points.